Welcome to Auxiliary Power Unit on the Airbus A320. We're going to be going over a couple of choices as far as models go that are installed in the Airbus A320 family. Now remember, the A320 family includes your A319, A320, and A321. And there are two models that are installed on these planes. And that would be your 131-9A. Okay, this is by GTC. The models GTC 131-9A and GTC P36-300. Okay, and just to keep in mind, the the 36-300 is not installed on the A319 or 21. And as far as the A320, it's actually installed on certain range of variants on the A320. Okay, that's actually between 3270, I believe, and 70 or 3271 to 78. Those are actually shown on the airplane. So when you see those numbers, or see that it's a number within that range, then you'll know that the GTC P36-31 is installed in that particular plane. Okay, objectives here, we're going to look at the components of the various subsystems of the auxiliary power unit. Keep in mind, this is just a small jet engine, so if you've already gone through the instruction for power plant, this should be a breeze. It shouldn't be that bad. Mostly we're just going to look at the components and where they're located, get a little detail about some of the valves, and again, just kind of get a feel for the APU and its applications. Just some of the different subsystems that we're going to go over is going to be the fuel system, of course, oil system, your air intake, and cooling. There's a cooling. Obviously, anytime you have an engine, you have to have a cooling system because a lot of heat is generated from that. And also know that the applications for the APU are basically so that you have a source of power on the ground. Of course, you have that in flight, and pilots have that available in case they need a backup. They have that APU. Now on the ground for maintenance, you can start the APU without, if, for example, you don't have power at the facility, you can always generate or get the APU going, which, by the way, is generated by a DC volt battery. Okay. The order that we're going to kind of do this in, I want to start with the brains of the operation, and that would be your electronic control box. Okay, that's kind of your center or your hub, where from there it's giving instruction to the different subsystems. In particular, we're talking about a lot of valves. So valves are going to be about valve positions, and of course this is all based on the demand requirements at any given time when it's in use. Okay. And then some of the indications we'll look at, obviously has its own kind of monitoring, self-monitoring. We have the bite. And then you'll also learn about this kind of shutdown and kind of the start sequence and shutdown sequence as well. All right, so let's go ahead and get started with the electronic control box, because that's the brains, like I said, kind of the brains of the operation. And what you have with the electronic what you have here with the electronic control box is a way to have communication to the different subsystems for distribution, for example, of fuel to the fuel nozzles. Also with the lubrication, so the electronic control box, or ECB, you may see it abbreviated, it's ECB. The electronic control box is also controlling the oil system as well, and also of course air intake and the cooling. All right, so let me go ahead and just talk a little bit about the electronic control box, and then also some of the interfaces with that, and then I'll kind of go back to looking at the applications on the ground and also in flight, and kind of a little bit of the altitude limit. Some of that may be on the test, so you'll have, if you don't have it already, you do have access to a variety of questions that a lot of them are going to be on the test. You don't know which ones they're going to be that are going to be on the test, but you have actually them in front of you. And as we go along in this video or audio instruction, you know, if you pay attention, you'll be able to get those the answers to those questions. All right, electronic control box. We have this electronic control box, okay, and it's basically your, you know, it's a little computer. Okay, if you took power plant already, then you're familiar with, or you took the section on FADEC. That's your full authority engine, you know, control, digital electronic control. And this is the same thing, electronic control box. Okay, controlling the operation and the monitoring of the APU. Okay, it does a lot of things automatically. So with that, it's just automatically controlling the engine start sequence. Also in charge of the acceleration and the demand requirements for, you know, whatever the demand is. It's going to make sure it has the right speed for, you know, obviously controlling the air to be, you know, necessary for those demands. And then of course temperature limits are important, so it's also monitoring that as well. Oil pressure, very important. Two things, you know, are going to be involved here, with just like with any system, is your temperature and pressure. Of course, we talk about quantity as well, but certainly the temperature limits, and that's what the ECB does. It makes sure that it's within temperature limits. Remember I mentioned about valve position, also vane position, because you do have an impeller with the load compressor in this, and I'll talk about that in a little bit. Right now I just wanted to get you familiar with the electronic control box and what it's doing. What is it controlling? What is it monitoring? Okay, so vane and also valve positions of different valves, which, you know, again we'll get into. Also your normal and protection shutdown sequences. It controls a lot of that. The other thing too, and lastly, is it actually stores fault indications. Okay, are the faults. So, you know, if it acts like it's just a storage place for that. You're gonna I'll probably mention a little bit about the data module that also stores fault messages. So that's its capacity. Okay, now a little bit on the interfaces. There's different things that it interfaces with. Of course, the master switch push button. I mean, APU master switch in the cockpit starts, you know, kind of kicks in the ECB, otherwise it's dormant. So till that APU master switch is turned on, nothing's going to really happen. So APU master switch turns on, or, you know, the pilot turns that on, then a signal, you know, is going to be sent to the ECB. You have also an air intake flap that is also one of the interfaces. Your intake flap, it opens and closes, so you have an open and closed position. So it's going to be getting the command to do that. Your power supply are going to be the aircraft batteries. Also, besides aircraft batteries, and you might remember from maybe some of the lessons you've taken with, you know, elsewhere, is your transformer rectifier units. Your TRUs, okay, are also a source of power for the ACB, generally for the APU. So you have a lot, I guess to say, a lot longer power source or power supply with having it drawn from the TRUs instead of just the aircraft batteries. But at any rate, that's what you have as a power supply and an interface. And then you also have, of course, the backup and the main start contactors. Those electronic, basically ECB receives that input from the contactors. Okay, and then the landing gear. I don't know if you've taken landing gear yet, but we talked about I have talked about the LGCIU. That's your landing gear interface unit. Okay, that's your gear control interface unit. Landing gear control and interface unit. And there's 1 and 2, of course, for one on each side, for the one on each side. And this is one of the things that the ECB is interacting or interfacing with. You also have your fuel feed system, because when we get to fuel system, I'll be mentioning that we're, the fuel supply for the APU is coming from your main, the fuel tanks, your main tanks. and those pumps that are in there, those feed pumps, are pressurizing the supply lines, okay, feed lines, to get that fuel to the APU. Of course, we have backups and all that, but that's what your main thing is there. So the APU fuel feed system. Okay, and then of course you have also the EIU. Okay, that's your engine interface unit. That comes up a lot in different things, and certainly here it definitely plays a part. Okay, so just some things to remember: power supply, air intake flap. Okay, that allows air to come in right into the APU, so it can start. It'll get into that into the plenum and all that. And I'll explain that later. But basically, so it can start that process of getting the APU running the way it should. Your emergency stop, also for emergency shutdown of the APU. You have your fuel feed system, EIU, and your landing gear control and interface unit. Okay, so those are your interfaces. Just wanted you to have some names in your head regarding that. Okay, all right, so we've covered some of that. There are other ones, of course, when we talk about that's in the cockpit itself. We have your the display, so your centralized fault display system. Okay, being able to see the fault messages on that when you run a byte. Your bleed monitoring computers, there are 2 of them. And these are important. Bleed monitoring computers are kind of the heart of things besides the electronic control box. I will say that. And actually we're going to have Rick talk a little bit more about those, but just keep that in mind. You got bleed monitoring computers, okay, that are monitoring that bleed air for the uses. Okay. All right. There's also remember I mentioned the data module. That's your data memory module. Okay, that's going to be storing operating hours and starts of the APU and things like that. Okay. All right. So so now you have an idea about the electronic control box. Okay. And I want to mention some the applications of the APU and also where it's located, and how do you access it, things like that. But let me just jump a little bit. What you're going to have, or if you haven't already been through these, I tend to go to the questions from time to time throughout the presentation, throughout the instruction, to keep it fresh as we're going along. And some of the material's been presented. It's good to get a little practice with a question. All right. So also, just want to mention one thing with the data memory module and the ECB. If you're going to be switching out or replacing the ECB, you don't want to be doing or switching out the data memory module at the same time, because you're probably going to lose data. Okay, it's one or the other as far as installation or replacing. You don't want to do both of those tasks at the same time with those 2 components. Okay, all right. And as far as location of the data memory module, that's located on the right side of the inlet plenum. All right. And let's see, let's get some, that, by the way, that was a test question. And I just want to kind of get a little bit, a few things here regarding the data memory and also the electronic control box itself. All right. Okay. So the electronic control box, can you name one interface? Okay. Yeah, I just mentioned quite a few of them. Okay, one of them's a zone controller. I didn't go into detail about that, but there's the zone controller. You also have a power supply, right? It's just a few. Okay, your landing gear control and interface unit, right? Okay. All right, so let's get to a little bit on the APU itself. And remember I said there's 2 models that you're going to be familiar with, become familiar with. That's your GTC 131-9A and then the GTC P36-300. Keep those 2 in mind. Just write them down on your sheet if you printed them out, which I hope you had access to a printer so you can actually print out the handouts with the questions, etc., because that's going to be invaluable to you when you take the test. Okay. All right. So, APU. What in the world is it? Okay, I'm going to just start from square one here. Your APU stands for Auxiliary Power Unit. And I don't mean to insult intelligence with anybody out there, but I do not take for granted that every single aircraft mechanic has the same knowledge across the board, because it's not true. So, Auxiliary Power Unit is just a small jet engine that you're running. It is located at the tail cone of the aircraft, so way in the back. And it's in the unpressurized part of the plane. Accessing it, there are 2 doors underneath the plane. Of course, you would have to have a way to, situate yourself underneath it so that you could actually, open those doors. And there is a way to open those doors, which we'll get to in a little bit. But there are 2 doors that open that you can access the APU. Okay. As far as the kind of engine it is, it's a constant speed gas turbine engine, in case you're interested in that. It's self-contained. Basically, it kind of runs, runs on its own, and it's providing pneumatic power as well as electrical power. Those are the 2 applications, or I should say, as far as power goes, is providing those 2. And the main uses of that is for main engine start. Okay, your main engines start, and also for your cooling. Okay, so we're talking about cooling for the cabin and cockpit. Basically your ECS, which is your environmental cooling system. Okay, so those are the 2, pneumatic and electrical. And there are limits for a pilot if he wants to, and some pilots may just keep it on, keep the APU on, master switch on. I know that some pilots actually, if they're going to go over water, they'll make sure that it's ready to go, meaning there's availability, or there's availability, but they just decide to go ahead and have it in operation. So again, it's just an extra precaution. If something went wrong with one of the engines, then the APU would already be in place to kind of take over a little bit, especially over areas where, there's really no safe area if you're up there 40,000 feet, but certainly over water. All right, so you have the APU in the back. You have the electrical power and pneumatic power that have altitude limits as far as its usage. And it varies, but do know this, when you have both, or when the pilot's using both the electrical and the pneumatic power in flight at the same time, it's only available up to 25,000 feet. All right. Okay, and if there's ever, a lack of supply, or there's insufficient supply of any sort, it's gonna have the electrical power be available over the pneumatic power in that case. Okay, but as far as in flight, remember, just a combination of both those available available up to 25,000 feet. Okay, and electrical power can be available up to 39,000 feet, but just electrical power only. Okay, also there is remember I mentioned the air intake flap as an interface with the electronic control box, your ECB. There is this intake flap, okay, and it does open when the master switch, I'm talking about the APU master switch, is selected to the on position. Of course, if you turn it off, then it's going to close that flap, because the flap allows that air to be taken into the APU. Okay. All right. So, kind of give you an idea with the application and kind of the altitude, or the altitude limits regarding the different supply that it has. All right. And then also what we have with the APU is just no different than power plant, where you have the different sections, and there's definitely more to talk about on the main engines, which it's more involved, but here it's just a small version of it. The design's a little bit different, so when we talk about APUs, we're talking about impellers, which we don't usually use that word. We're not using that word when we talk about the bigger jet engines. Obviously the main engines are master engines as it was in the past in 1970s, but your APU does have the 3 sections. It still has to have a way to take in the air, all right, and then compress that air. So we have a load compressor now. I just introduced a new component to you, is the load compressor. And then you have, you've got a power section there. Of course, you got the exhaust section after that. But you've got to have the air come in and then get compressed and then mix with the fuel mixture. So you have fuel air mixture in the combustion section, okay, your turbine section. And then after that, you have an exhaust area. Now, as far as your accessory, because one of the things that, or 2 things that the APU drives in order for it to, you know, provide the pneumatic and electrical power, is it's driving the load compressor and also the gearbox. The accessory gearbox, okay, what is it, you know, what is it driving? Okay, you got shaft power that's going to be going to those different subsystems I mentioned. Okay, so on the drive pads, you're going to have your fuel system, oil system. Okay, also you have a cooling fan as part of that as well. Okay, let's get into a little bit on the power section. I know I mentioned about the load compressor air coming in, right? We'll get more into the, I'm going to talk about the air intake system in a little bit. Right now I just wanted to kind of section out the APU. Your power section, this is going to be where you have the compressor. The compressor, just know it has diffuser vanes in there. It has different kinds of vanes, and you have an impeller. These components are part of the compressor, specifically engineered to take in that air a certain way, okay? Because it needs to be ideal in order to get into the next section. We're talking about the, you know, where it's compressed and then ready to be mixed with the fuel, and then of course going to the fuel nozzles. All that going in the fuel nozzles that goes into the combustion chamber for that thrust. Okay, all right. So the combustion chamber. Okay, we have in the what I mentioned just a bit ago with the compressor. You have an impeller and 2 kinds of vanes. Okay, VANES, by the way, and then you have the combustion chamber, where you've got obviously, you know, like I just mentioned a bit ago. And there's an inner and an outer combustion chamber shell for that. Part of the components there is the igniter plug. You also have fuel nozzles, like I mentioned earlier. There's the monitoring of how much and how fast, you know, what's the rate at which the fuel is going to the fuel nozzles. That is all coming from the electronic control box, which is getting input. Okay, so, you know, it can know how much to put in there based on the demand. The turbine assembly, all that is driving the compressor, the low compressor, and also the gear train of the gearbox. That's what the turbine section is doing. And the turbine section, what do we have? We got rotors and stators. That's part of the turbine section. The rotors and stators. You've, you know, got the blades, you know, as well. Okay, your first stage blades. All right. And your inlet guide vanes, I'm just going to mention that briefly. Your inlet guide vanes are very important. They are, remember I said how important the way the engineering is of the vanes, because it's important to have the air directed a certain way. Okay, well, this is what I'm talking about with the inlet guide vanes. It's controlling the amount of bleed airflow coming in. Okay, and also the pressure, so because of the way it's designed. So it's pretty amazing, I think, the way that it works that way. You have 16 of these inlet guide vanes that are moving, of course, have an actuator that's operated by a gear train. So you have those moving, so there's 16 of those. Okay. Remember, bleed air is predominantly here for main engine start. Okay, so bleed air on the APU, its primary purpose, okay, is really kind of a boost. It's a booster engine. When we talk about boost pumps, right? When pressure drops past a certain PSI. Well, it's kind of the same thing here. If, you know, it's kind of giving a little boost to the main engines for starting. And you can see diagrams of here where you have the accessory gearbox or gearbox, and you have all the drive pads on it. And that's going to be your starter is going to be there. Remember I mentioned the fuel. You have a fuel control unit. Okay, that's your FCU. I'll talk about that when I talk about the fuel system, but you do have that assembly there. And then you also have your lubrication unit, a generator, and your cooling fan. Your oil tank's at the bottom. Okay, it's at the bottom of the gearbox. Okay, all right. All right, so that gave you some ideas on the accessories, because I mentioned them several times. And they're, on that gearbox, and then, the different sections of the APU, how important it is to have the inlet guide vanes a certain way, designed a certain way, to control the flow of air coming in. All right. Okay. All right. Let's go ahead and go over. And there's some. And I remember there's really not too much of a difference between the two models. I will mention that right now. 131-9A and your 36-300 as far as these APUs. They have to have the same subsystems to run, right? It's just it might be slightly positioned differently. And also too, another thing, as far as ground maintenance and your use of the APU, you can if you're working on an aircraft that has the installed with the 131-9A, you can actually do testing of the anti-wing icing. Okay, that you can do. Can't do it if you have if you're working on an aircraft that has the other one on it. It's just not possible. So there's like little nuances like that, and we'll have some more information as far as the little tips and kind of like nooks and crannies, if you will, of the maintenance world as far as this goes, just from people's experiences. And if you've never worked on APU, this will be extremely helpful. So just if you want to know where that's located on the website or how to get to that, just email us and we'll let you know. But here we will be having another kind of question and answer style of presentation or instruction. All right. I'm going to go ahead and we're going to start with and there's also indicating as well, but I really want to talk about the fuel system right now. So, and then I'll probably just go into oil, or I might just go into air intake, and it's kind of like, well, air comes in first, right? But you have all these different components, or the accessories, and I just wanted to get to talking about those accessories. Your fuel system, okay, it's very important, obviously, to have fuel. It just kind of goes without saying, right? Shouldn't have even said it. But the fuel system is run automatically. It's fully automatic. Okay, what does that mean? That means when the pilot switches the switch of the APU master switch to on, it's sending a signal, okay, a discrete signal to the electronic control box. And that's giving signal for that automatic running of or operation of the fuel system. With the fuel system shutoff valve, that's powered open, and then you also have the inlet doors that are opening as well. You also have the fuel that's going to the FCU. Okay, that's your fuel control unit. It's going to be measuring quantity based on the demand requirements. All right, your fuel supply, fuel pressure. Of course, you always have to watch these things with temperature, etc. But it's monitoring all of that. Your supply is coming from, it's coming from the main engines. I mentioned that a little bit in the beginning. The fuel tanks, the aircraft tanks. That's the source. Now there is a boost fuel. The APU has its own fuel pump, but the pumps I'm talking about are the ones in the tanks, or the main engine, or for the main engines. Okay, those in the fuel tanks. So that's how it's getting there, and then of course you have feed lines going to the APU system. On pressure, there's two pressure switches. Okay, on the pressure. Okay, fuel pressure. Because again, you've got to pump from point A to point B, right? So you've got to move that fuel. Just same thing with the oil, right? Anything that has to move from point A to point B, as far as a liquid, you have to have something pressurizing it to move it. Here you have two pressure switches. One's on the fuel lines. You've got one on a supply line, and it's basically to ensure, again, like I said, from in the main engine fuel feed pumps, where they're, you know, in the tanks, and then going into the fuel, into the APU fuel system. Okay, and then all right, so you have that with the fuel pressure, and then also, of course, you have vent valves, and you can see some of the diagrams that will show, you know, where those are located. Okay, and of course, what gets shown on the display. And actually, Rick's going to share at some point, in one of the videos, it's going to show or share with you kind of a malfunction of an APU, and you know what happens, what's happening. All right. Okay. All right. Now, what makes up the fuel system? Okay, I just said it's fully automatic. We have a couple of pressure switches. Obviously, something has to get from point A to point B, namely fuel. But we also have fuel filters. We also have a torque motor. You've got a shut-off solenoid as part of the fuel system components. You also have two manifolds. You have a primary and secondary fuel manifold. You also have the injector nozzle and your flow divider. Okay, and of course I mentioned this before, but your FCU, your fuel control unit. This is mounted right on the lube module. Okay, so that's where you'll find that. It's and also with the and then I just want to mention the fuel flow divider assembly. That's actually installed between the FCU and the two manifolds. Okay, as far as where that's located. All right. All right, just a little bit on the fuel control unit, and then I'll kind of go through a sequence a little bit with you regarding fuel, and then we'll move on to probably just go ahead and move on to the air intake system. All right. Fuel pump, have to have pumps. You can remember I mentioned you have filters, your fuel shut-off solenoid valve. The fuel filter is located on the FCU. Okay, so if you ever asked a question, where's the fuel filter? It's on the FCU. Okay, obviously it's filtering that fuel, because you don't want to have anything, whether it's going to HMU, we talk about other systems, or FCU, you don't want to have tainted fluid going into those units. So there is a filter before it goes to the FCU. Okay. And as far as there's different kinds of fuel filters. This one is a 10 micron, so it's really obviously rated for that particular application at that point. Okay, you also have a modulating valve, the torque motor. Okay, this is a torque motor valve, torque motor modulating valve. That one's on the right hand side of the FCU. Okay. And the way that there's the metering of the fuel control is through the torque motor. Okay. And then there's also the shut-off solenoid. That's also mounted on the FCU. And that closes on command from the electronic control box. And that's in order to supply fuel. Okay. Remember, when you're closing a circuit, things are great. When they're open, things aren't happening. Okay, that's the way it goes. All right, so that gives you an idea with that. And the flow, I mentioned the flow divider. You get your primary and secondary fuel manifold. Those are, you know, there's different size fittings on each of for each of the ports on those two, so don't get them, there's no way you can get mixed up. I mean, a lot of these things are marked so that there's no way you could, put it the wrong direction. But the ports are different sizes, so obviously you're going to know if you have put something in the wrong port. But at any rate, I do want to say, please follow the aircraft maintenance manual. Okay. All right, so it kind of gives you an idea with that. I'm going to just go ahead and move on to the air intake. But before I do that, I do want to mention that the APU master switch, when it's on, what happens? Okay, remember I said now we've got a signal going to the electronic control box that then what is starting that fuel system to be fully automatic. Now at 7% speed, okay, of the APU, then you're going to have that fuel shut-off solenoid I mentioned a bit ago. That's going to start opening. Okay, then from there, you've got fuel coming from the FCU pressurizing valve that will flow to the flow divider assembly. Okay, and after that, it's energizing the ignition system. Okay, now I don't know if you're familiar at all or been in classes with APU, but after a certain speed, it stops but basically it's starting enough that it's going to be running on its own momentum, and that's what happens at 50% speed. Is the electronic control box is going to de-energize the starter motor. Okay. Okay, so I just want to say that to you. All right, let's kind of jump over to a few test questions, and then we'll get back into our lesson instruction here. All right. Okay. I didn't mention this, but I'm going to go ahead and tell you now. But here's a question. Just look at your handout. It's actually number 9. Where is the electronic control box located? Is it on the left or the right side of the rear cargo bay? Okay, it's on the right side. It's on the right side of the rear cargo bay. Excuse me. Okay. How many IGV, I'm talking about the inlet guide vanes, are there for the 131-9 model of APU? Okay, is it 12 or 16? I did mention it. Okay, it's 16. Okay, that's number 10. All right. And how about another question? How about number 6? Okay, you see that on your sheet. What component is the brains, so to speak, brains of the APU? Is it the auxiliary controller or the electronic control box? Yes, it's the electronic control box. I've been mentioning, we've been talking about that ad nauseum here. Okay, let's see. Number 5. Let's do number 5. All right, the 2 typical APU models used in the Airbus A320 family are the GTCP 131-9A and the GTCP 36-300. Is that true or false? Yes, it is true. That's absolutely true. I'm talking about that. All right. All right, let me just, I'll stop there and we'll go ahead and go back to our lesson a little bit. Okay, we're going to get into air intake, but I do want to throw in a little bit of information here that's on altitude limits because you might see that on a test. So I thought I would bring this up to you. All right, let's look at some operating limits. And this is going to be, you know, I mentioned earlier about the 39,000 feet max for electrical power of the APU. That was on the 131-9. Okay. All right. Let me just share a little extra with you. Maximum altitude for the APU operation on electrical supply. Okay. Remember I said 39,000 feet in altitude. Okay. Now there's a limit with the use of the APU as far as starting it. Okay. So if a pilot needs to use the APU and his altitude is at 31,000 feet, can he start it? Okay, is it yes or no? Okay, the answer is no. He has up to 25,000 feet to start that APU. So there's a max limit for him to do that. Okay, also if a pilot needs to use the APU for electrical and pneumatic supply, okay, and he's flying at 18,000 feet, can he use both of them? Because there's a max too when you're combining the use of both of those. Okay, the answer is yes, he can. Because he can do that up to 25,000 feet in combination. Past 25,000 feet, he cannot. Okay, that's question number 4. Okay, the one I gave you earlier was question number 3, and then that one before that is question number 2 on your sheet. Okay, So those are just operating limits. Just wanted to give you an idea on those. All right. Okay. I want to make sure I cover things that you have on your sheet. If you have questions, if for whatever reason I missed one and you saw it, we didn't cover it, or whatever you missed it, just let me know, or you just email, and then I can help you with that. All right. Number 11. Okay, this is on your sheet, your practice sheet. The inlet guide vanes control the amount of bleed airflow from the load compressor. Is that true? That actually is true. That is true. Okay. All right. I didn't mention the number of fuel nozzles, but I am going to mention it now. They are part of the combustion section, and there are 10 of them. There are 10. Okay, on the main engines, by the way, there's double that. Okay, well, this is just a small APU. There's 10 fuel nozzles. Okay. All right, and just remember, if you're hearing this instruction and you're at the same time you're looking at those questions and you're hearing the answer, fill it in. Go ahead and take your pen and just write the answer right there next to that question. Okay, and if you didn't hear something, or you missed it, just let me know and I can help you with that. Okay. All right, let's do one more question, then we'll go back to our lesson. What modular assembly is between the power section and the accessory gearbox of the APU? Is it the turbine frame assembly or the load compressor? Okay, I actually mentioned that. It's the load compressor. Okay, the load compressor is between the power section and the accessory gearbox. Okay, let's go ahead and get back to some information here. Your familiarity, and the objective here is just to become familiar with some of the component names. Where are they located? How does one thing interface with another? How does it work? All right, air intake system. This is for the 131-9A. Keep in mind that there may be a couple of nuances with the 36-300, but I mean, it's pretty much the same. Okay, and those details we're going to share as we get that information. We definitely will pass it on to you. All right, air intake system. What are we talking about? Okay, that's just no different than main engines, right? It's all it is. Taking the ambient air and bringing it into that whole system and compressing that air, and then diverting it, and just we got different things going on. So with here, the components are your diverter, your air duct, and your air inlet, which is you have your inlet intake flap. Okay, that's part of it. Your air inlet is an assembly. It's installed as a unit, so if that needed to be replaced, you're replacing the entire assembly, and it can be removed fairly easily. Okay, it only has 4 bolts that are connected to the bottom of the tail cone. The air inlet body is also there. It's a U-shaped component, and then remember I mentioned your air inlet flap. That's important. If there's a failure there, which I'm going to find, we'll find out just how frequent it happens with that, because I think that probably can be likely as a problem, and something you can kind of, when you're troubleshooting, you can kind of go with what's more common of a problem and address that first and test it to see, if it truly is it's not working, if it fails. Okay, your diverter, you got your diverter, which is installed just forward of the tail cone. That's at the bottom of the rear fuselage. Okay, what is this here for? The diverter's diverting what? It's diverting the air. Okay, it's improving that ram air recovery during in-flight, when it's operating in flight. Okay, so that's what you have there, and then like I said, you got your inlet body. Okay, and you got these little you got your hoses in there, housing, and just different little pieces in there, seals and whatnot as part of that. Okay, all right, your air duct as one of the components actually has 2 major components. Okay, they're joined by brackets and fasteners. And what you have with this, you've got an elbow as well. The purpose of the elbow is to redirect the airstream into the chamber. Okay, it's the plenum chamber of the APU. Okay, so you have that, and then the diffuser. What that's doing is decelerating, the airspeed. It's decreasing, it's diffusing, so it's causing a slowing down of that air. It's kind of working together in conjunction with everything else. All right. Okay. You have also two different actuators. I did want to mention that because there's a lot of different things, but I'm just giving you the main components, and I just wanted to mention about the actuators. There's two different actuators that you can install. Please pay attention to part numbers that are on the tags, because obviously there's a lot of things that look alike, and you think, oh gee, that goes there, and you didn't pay attention to the part number. That was what was required from the aircraft maintenance manual to use. You've got two. One is requires 47 turns on the manual drive. Okay, and you have another one that is requiring 87. So how are you to know that? The fact is that actuators can look very similar to each other, right? But there are two different kinds, or two different types of actuators there. Okay. All right. That's what you have with the 131-9A. You have the same thing for the most part. Okay, I'm saying for the most part with the 36-300. Please pay attention to the aircraft maintenance manual, and specifically which APU you're working on, because they are very similar, but there are a few those are just some nuances in there, and you don't want to be just raise your awareness about that. There's a retractable diverter on the 36-300. Okay, it's also installed. That diverter is installed in the same place that was installed on the 131-9A. It's just a little bit different. Okay, and with the diverter, it's here. It's just making sure that fluids. Okay, you could have all kinds of stuff. I mean, you got oil, obviously. You got hydraulic fluid. You've got de-icing fluid in those lines. You got fuel, water, things like that you don't want to get, into the APU during flight or otherwise. But all that stuff, while it's running, in operation, if it's running, it's obviously there's a potential for some of that fluid to get into APU. So you don't want that, and that's what that diverter there is to prevent, all that from entering the air inlet, so it doesn't go into the APU. Right there. Okay. All right, so that kind of gives you an idea. I just mentioned some different components, your actuators, and you got air ducts, your air inlet body, your air intake flap. Okay, opens and closes when APU master switch is on. Okay, so that's pretty much what you have with that. Rick's going to get more into the operations or indications, and also just from cockpit orientation, since he's a pilot, and he can give you a lot better perspective on that when you're seated to do maintenance in there. All right, so that's your air intake. I covered fuel, so we have fuel system as your subsystem. You always have your air intake system. There are APU drains. I'm going to just interject this here before talking about, we'll go into oil next. But APU drains, what's the drain system? Okay, we got fluids that are running, different kinds of fluids. If it's iced over and it melts, we have water that's collected. So drain system there is to ensure that all liquids or any kind of fluid that's present is going to not be staying put there, but actually gets exited out of the APU. So you have this here. It's collecting it and it's just kicking it overboard. All right. Components that are installed on this, they are actually installed on the right hand compartment access door. is you have your left and right compartment access door. Remember I said there's two access doors underneath the plane where the tail cone is? Okay, there's a right side and a left side. Okay. Your forward and mid APU drain ports. Those are providing a way for your cleaning fluids and water to drain from the APU. Okay. And also it does another thing. It's providing a way for the fuel to leave also, because there may be fuel that accumulates in the combustor, especially if there's not a clean burning. If there's not a clean burning, and then you're going to have some of that fuel left over, and that needs to be removed, and the drain does that. On the ground, you've got cold drains, so that was like a mixture of, you have oil and fuel, for example, that can be collected in the drain tank. In flight, if you have low pressure is generated at the drain mass so it allows the discharge, of the liquids. Basically, getting it suctioned out through through the lines and exiting overboard. Okay. And of course, when we're dealing with liquids of any sort, you do need to pay attention to leaks, and also just pay attention to the aircraft maintenance manual regarding leak limits, because a few drops of oil may be okay, but a gallon may not be. So I'm exaggerating, but certainly if you see there's something that is dripping too much, there's normal drip, so that's okay. If you're not familiar with that you might think, oh my gosh, that's not a good thing, but maybe there's something wrong, but in some cases it's actually totally fine. So please pay attention to leak limits in the aircraft maintenance manual. All right. Okay, let's go ahead and switch to oil. We're going to get into oil, and then we'll kind of go into our start sequencing and shutdown to give you some familiarity with how, what that process is. But let's go ahead and do oil right now. All right, with your oil system, let's go ahead and start with this, and then I'll have a couple of questions to ask you kind of in between. Actually, I should give you a couple right now. Okay, so don't forget, if I missed a question again, let me know. But here we go. Let's throw one here. Oh yeah, and access on the doors. The doors themselves, I do want to cover that. Let's just kind of go over a little bit. You have a left and a right access door, okay? And in order to access the APU, you have to have the left door needs to be opened first. So keep that in mind. Okay, that's number 16 on your sheet. The left door needs to be open first before the right one, in order for you to open the door so you can get access to the APU. Okay. And then on latches, there's 7 latches total. And that's total meaning on the doors. Okay, so in order to unlatch the left-hand door, you're going to unlatch the front latch last. Actually, that's number 17. That statement is actually false, because you're not unlatching the front latch first. You're doing that last. Okay. All right, now I'm going to go back to our lesson. All right, let's do on oil. Okay, we're going to talk about the oil. Remember, there's the lubrication units on the gearbox. Your lubrication, of course, is important for what? Besides lubrication, is also to cool. That's its other function. So it's there to cool the power section and gearbox, and all that. You have a wet sump lubrication system. You also have a monitoring system as well, because temperature and pressure, right, are very important, and they need to stay within certain limits. Your ECB is monitoring the oil system. Remember I said in the beginning the ECB is the brains of the operation, and it's getting, sending signals to the fuel, oil, air, and cooling system. Okay. Your components that you have 2 oil filters, you've got an oil heater, You have a low oil pressure switch, as well as a low oil level switch. You have your air oil separator, because you don't want air in the oil. Air pockets, that becomes a problem in the function. Thermal bypass valve. You also have an oil cooler assembly. Pressure switches, obviously filters, and of course your module itself. Also, when you're dealing with oil, we want to capture little particulates, you know, metallic particulates, and therefore you have the chip detector, magnetic chip detector as part of that. Okay, all right, so your interfaces with oil is you have your indication system, oil indicating system, your control and monitoring, and of course your accessory cooling system. Okay, now storage, there's an oil tank at the bottom of the gearbox. That's what I mentioned earlier. That's where it's at. The storage of the oil is there at that lower part of the gearbox. That's part of the oil reservoir of the APU. Okay. Now, question is, how much oil, this is not a test question by the way, but you might as well be aware of this. Oil quantity, how much oil can the oil tank hold for the APU? Okay, it's about 6 quarts. Okay, that's about its capacity is 6 quarts. Okay. All right, and of course you have an indication on there that shows low oil level. You probably have seen those before, but that's going to be also indicated in the cockpit on the ECAM. All right, and also just a kind of a safety thing. Obviously, if you're dealing with oil or any fluid whatsoever, make sure that you want to keep minimal contact or zero contact if possible with any of the material. Okay. Also you want to make sure you have personal protection on you, like gloves, and we're talking about gloves that are designed to protect your hands in case you come in contact with the oil. All right. Okay. And of course, you do have that magnetic chip detector, just like you have in all oil systems, because you don't want to have those metal particles in the oil that'll damage components along the way, and we want to not have that. So the whole idea here with the detector, it's being able to capture those particles. That's actually located on the lower front face of the gearbox assembly. Okay, and of course you have a drain plug along with that. All right. And your lube module, it's called a module. It's not just obviously lubrication, but it also regulates pressure, and it's also filtering. And again, it's lubricating any of the bearings, but that's what it's for. Okay. All right. So that gives you an idea with the oil system. And I'm going to get into oil filters. I mean, you got filters there. There's also a cooling fan. If you look at the diagram, you've got, remember, kind of the components on the drive pads of the gearbox. You've got your starter, you got the fuel, the FCU, your fuel control unit, a lubrication like we're talking about right now. Well, there's also a cooling fan. Okay, you got a cooling fan there that's just allowing air to be there to dissipate any heat from the oil cooler. Okay. All right. It gives you an idea on the oil system. Let's go ahead and go into a little bit on the starting sequence. Indications, I'm going to let Rick expound on that. I'm definitely going to cover some of that, and then we'll go into some of the review questions. But your start, kind of your start sequence. Okay, your starting is going to be. Okay, remember I said everything starts with the APU master switch in the on position, right? So that's where it begins. Let's go ahead and go into that. All right, let's go. Let's see. Ignition starting, like I said before, with, you know, the APU's master switch turned on. Now you've got the ECB coming alive, okay? Before it's kind of lying dormant, if you will. But then it starts automatically with all of that. Okay. All right. So what do we have here with this? We have your normal start sequence. We also have abnormal meaning emergency shutdown. But here, let's just talk about the normal start sequence. APU is going to start. And remember I said about that, you know, at 7% speed, you know, you have some certain things that are happening or being opened. And then at 50%, you have the de-energizing of the starter motor. Because by that point, you know, the APU's gotten enough speed to kind of run it on its own momentum. And that's what happens at that point. Here on normal start, you've got the APU start at 0 speed, right? 0% speed. Starter's on. All right, and the contactors are going to energize, so they're going to close. So you have the starter motor starting up. Okay, that's going to start turning. You have your solenoid that's going to open, and that's your D-oil solenoid that's going to open. You also have the energizing of the fuel flow divider solenoid. That's going to start going. Okay. And then remember I said about 7% speed, you're going to have the opening of that fuel shutoff solenoid valve. Okay, and that's in the fuel control unit, your FCU. Your ignition is going to be energized, and your inlet guide vanes are going to close at 7%. Okay, at 30% speed, the electronic control box is going to cause what? It's going to cause a de-energizing of the fuel flow divider solenoid. Okay, at 50%, what happens? At 50%, the start contactor is going to be de-energized. Okay, that switches off the starter motor, like I said a bit ago. Okay, and then you have at 60%, you have the de-energizing of the ignition unit. And then at 95%, then you have automatic control. ACB is controlling and monitoring the APU automatically. Okay, that's your normal start sequence. Now your normal shutdown, because you have a normal shutdown, we talk about emergency, that's your abnormal. But right now, just kind of go over the normal shutdown. Normal shutdown obviously is coming from 100% speed. If there was no bleed air being used, then the loads are going to be removed. Okay, they're not going to be there. Overspeed test is performed, so at that point it's, you know, doing a shutdown logic. And then you're going to have the closing of the fuel solenoid. Okay, so it's kind of working its way backwards. Okay, at 95% speed, the APU start, push buttons available. Light, that one extinguishes so you don't have that light showing. It's just all going backwards. Okay, and it's just shutting down. Okay, basically the reverse of everything I just said. Okay, and indications, you're going to see on the system display your power indication, like you said, I was mentioning the blue, well, it's a blue light actually. A blue light means available. That will actually disappear. That will go out. Your temperature indicating, okay, that's actually monitoring the EGT. Very important, your APU exhaust gas temperature. Same with any engine. Okay, your EGT is extremely important to thrust. That's a whole discussion. If you're interested, we certainly would love to share things like that. Right now, you just kind of get in the nuts and bolts, pun not intended, by the way, the nuts and bolts about the components and the indications and where they're located and your access for, you know, for maintaining them. APU life data, those are on your MICDUs for indication. So you'll see the serial number there of the APU, the operating hours, the cycles, you know, things like that. Okay, you also have your power indicating as well. Okay, Of course, with temperature, that's another thing it's monitoring. Remember what I said, we're dealing with an engine, so there has to be a monitoring of temperature. But you have, of course, thermocouples are there, being able to, as sensors, to make sure that, or just send information to the ECB for then giving command, because it doesn't want to have an overheating situation. All right. Okay, so that's what you have with that. Okay. And their total pressure transducers, those are located on the right side of the inlet plenum. Those, I mean, obviously pressure is also monitored and very important. So you have those transducers giving that information to the ECB. So ECB can give the right information to monitor, to keep things within pressure limits. All right. Okay. Let's go into a couple of more practice questions, maybe 3 or 4. All right. Let's go to on your sheet. Let's go to question number 21, which is not what we covered right now, but this is something you can be aware of. What's the red colored pip pen used for? This is, part of the accessing, or what's on the access doors. Okay, the red colored pip pen is used for, it's for the first choice. It's a locking device for the right hand door. Okay, if you needed to remove that door, you would use that pip pen. All right, and just like, you probably, hopefully you're not guilty of doing this, but I mean, these are things that people have written about or, advertised on the YouTube, but is some of the carelessness of aircraft maintenance technicians. Obviously not all the time. I would say it would be it doesn't happen that often. Often I would think not, but not latching everything down, especially if you're just getting in a hurry and you're not latching everything down. And we've had, of course, engine cowls come apart because they were not all latched. So that's question number 22. After closing the APU doors, what's the most important thing you could ever do? Okay, the answer is the second one. Ensure that all the latches are secured properly and firmly. Okay, I know you can be rushed, but even in a rush, believe it or not, you can actually learn to still be deliberate and get everything done that has to be done the right way. Okay. All right, question number 23. Before accessing the APU doors, what must you do first in the cockpit? And one of the things you want to do, if you're going to access the APU doors so that they do open, you need to keep those circuit breakers open. So that needs to happen first. Open the aircraft circuit breakers. Okay. All right, what sets the position? And again, a lot of these questions, well, some of them are going to be in the test. I can't tell you which ones, but I will tell you this is extremely helpful to have this handout in your hands. All right, number 25. What sets the position of the inlet guide vanes? Remember I talked about the inlet guide vanes. Okay. I didn't mention about the fuel servo actuator, but it is that. The hydraulic fuel servo actuator is what actually sets the position of those vanes. It's not the low pressure bleed air. Okay, it doesn't make any sense. All right. And if you're shutting down the APU, okay, how long should you wait after that shutdown before servicing it, say for oil? Is it 1 hour or 30 minutes? Okay, the answer is actually 1 hour. Okay, you learned something, I hope. Okay. All right, that covers a lot right now. I mean, we covered the electronic control box. Remember, that's the brains of the APU for it to actually run. Number 2, the different subsystems. Those are going to be your fuel, oil, your air system. Okay, and then you also have your start sequence, normal shutdown, just kind of explaining the different APU percent of speed in which things start to shut off, like for example your starter motor at 50%. things start to open or close. So basically that's just giving you the gears that are going, figuratively speaking, by the way, the gears that are going when you hit the master APU master switch to the on position. Okay, and remember the ECB is doing what? Is controlling not just the engine start sequence, but it's also controlling the acceleration. Remember, it's in charge of handling the demand requirement at any given point in time. So ECB is controlling that governed speed. The operations of the temperature limits, also pressure, the vane positions, and valve positions. Okay, and of course, one extra thing that ECB does, it stores faults. All right, so I hope that gives you a pretty good familiarity with the APU, and remembering that its main objective is to start the main engines. And aside from that, its job is to cool. So it's providing pneumatic power so that you have air conditioning, so it's your cooling system in the cabin and cockpit. Okay, and that's, you know, there's different valves, you know, with all of this. If you have anything specific that you're curious about, you know, we can get an answer for you. Okay, all right. Well, that concludes that. I do want to mention a couple of more questions. I know it seems like I have 1,000 questions, right? But you know what? A lot of these, you know, I know you don't know which ones, but you just never know. But the ones we covered, I would put a star next to them. That tells you anything. Okay, let's do question. Let's go back to your sheet, and let's start with question number 1. Okay, I know it seems so simple, but I'm going to still verbalize it. Which power supply has priority over the other? Is it electrical or pneumatic? Okay, I remember I was saying electrical. Electrical supersedes pneumatic. Okay, if it came down to one or the other, electrical is going to be running. And by the way, electrical runs a lot, or can operate at a higher altitude than pneumatic. So your max limit, operational limit for electrical power is at 39,000 feet. Okay. All right. I want to make sure I didn't miss any questions that you can write down some notes about. All right. On the doors, I just want to go back to a little bit on the access doors. The left-hand door is the one that requires a support strut in order to hold it in place, locked in open position. So remember, left-hand door requires that support strut. That's a true statement. The right-hand door does not require a support strut. So number 19 and number 20, if you're fishing through your handout right now, question number 19 is not true. It's a false statement. And then question number 20 is true. You do need a support strut for that left-hand access door. All right. Okay. All right. We're just going to call that now. If you have any additional, or if you have any questions at all regarding the material, or again, just certainly email. You can do that anytime, because, you know, obviously you can take the test whenever you feel like it, you know, whenever you're ready or have time. So, you know, before that time, of course, you can ask, you know, questions. All right, well, look forward to, I hope you got a lot out of this, and we look forward to providing more information for you in the other instruction.